everybody, and I'm going to talk about moving towards energy efficient labs. So in terms of the NIH, we are the nation's biomedical research organization. In terms of real estate footprint, we comprise about 14 million gross square feet. Of that, 10 million gross square feet is laboratories. So one thing about labs are they're highly energy intensive, use about 4 to 6 times more energy than a commercial office building. So according to Labs 21, which is a consortium between EPA and the Department of Energy, they say basically 30 to 50% of the energy that is used in labs can be reduced by using current technologies. And here's a pie chart that basically shows how the energy distribution is in the lab, and about half of that energy is used with just moving the air and cooling the air is where a lot of the energy is being used. So how expensive is biomedical research? So this is our typical energy bills we see per month, about $5 million. Overall, for the NIH Bethesda campus, we spend over $70 million in utilities empowering the campus. One thing about NIH and sustainability, it does align with our mission in terms of if we can offset those, reduce those emissions from the production of energy, it does reduce the effects of health, environment, and social impacts, and also furthers our commitment in reducing our carbon footprint for national goals. But the other thing is that we can also further our research mission by shifting those dollars from operating costs to obviously helping our research and procuring more lab equipment or doing more trials. So it's actually two things that benefit from looking at sustainability aspects. For the Ignite study, one thing about NIH is we operate a vast array of different types of laboratories, and there is not one single design standard or method of operation of how we can reduce this energy, so we do need to do research in that. So the one thing about the Ignite study is, one, look at what simple things can we do in the lab to save energy, and two, can we refine these design standards, and do they make sense in terms of how we look at designing our laboratories? So one thing about the Ignite results that we've done is starting to build a database on our plug load equipment to refine those design standards. Plug load equipment is essential in how we design our HVAC systems, and revising those standards of what makes sense is what we're looking at, and then establishing benchmarks for our plug load equipment. There is no Energy Star that tells you, hey, this equipment's better than the other. So really getting these benchmarks and establishing those guidelines and procurement guidelines in the NIH for what is efficient and get the job done, that's basically what we're starting to build with the panel meters that I did procure from the Ignite funds. Some of the other things that we looked at was looking at biosafety A2 cabinets. One of the things that I noticed in one of the labs while I was doing the studies was one lab does turn them off. Most of the time these lab researchers leave them on the whole time. But one thing that I did notice for the one lab that did, and I measured that differential just in the overlay of the energy, saved about $250 a year just looking at if they just turn it off for just 12 hours a day. That's about 6-week payback, $30 timer that you can just install. So that's a little simple, low-hanging fruit that we can return some money. Some of the other things is looking at freezers. We operate a lot of this, about 6,500 on NIH. They use as much energy as a house, and basically compared to a 10-year-old freezer, which is about the average age that we have, you can save about $400 with just selecting a much more energy efficient one compared to 10-year-old models. Some other things I noticed was a lot of equipment wasn't maintained. With our freezers, this is a picture of a dirty filter, but obviously you can see depending on how soiled the freezer, this was actually the worst I've seen. 12 to 25% energy consumption, and incubators, I noticed that there was a 15% more energy consumption from there. So some of the things that we're looking at, with the Ignite funds, I was able to buy 2 panel meters, 9 energy watts up meters to measure energy consumption individually, but I would like to purchase 10 more so that I could do more advanced studies. So some of the things that we're looking at is obviously measure more lab equipment, but the other thing is we noticed some operating trends that we can improve operations in our labs, but obviously I would need to measure for longer periods of time and monitor multiple circuits simultaneously to obviously look at how we're looking at our reheat in our HVAC systems, also getting an understanding of what the diversity of how our labs fluctuate, so obviously we would need longer periods of study. And so anyway, thank you for your attention, and thank you for the Ignite team. And this is basically the team that helped us with development of this project. And any questions?
Guys?
I think that, savings are always important and people love it, and then if you're not careful, they just sort of say, great, then we don't have to give you that much more money anymore. How have you used those savings, or what are your plans for whatever savings you can capture? How are you going to divert those funds?
Well, we've done it already once with some of our projects. So one of the things that we did do was do a freezer replacement program. So we took $660,000 to buy 107 more ultra-low temperature freezers. I mean, they're about 10,000 a pop. So we were able to use that to buy more scientific equipment, and obviously much more energy efficient than the predecessors that were replaced. So those are some of the things that we were able to roll out. Now, it's kind of different because it's from our utility fund. So basically what we did, we solicited a program. It's like, hey, Cash for Clunkers is basically how we called it. And the researchers nominated their freezers. Obviously, I validated the energy savings with energy monitoring panels, but and that's kind of like how we reached out, kind of talk to the community to say, hey, if you turn off that light that's unnecessarily, or if you turn off that equipment that's unnecessarily, then you can kind of feed it back to the research community. So those are some of the things that we're thinking about in terms of promoting that behavior change and shift within the research community. I mean, we can design facilities one end, but trying to leverage the behavior aspect in the operations is also that almost that untapped.
Sure, and actually because of that, if you haven't already, I would love for our staff to then reach out to you and sort of learn from you what is it that we can, I mean, we have the same issue. We have a lot of labs that are all different standards, different needs, but we know that efficiencies can be accomplished across, so we'd be more than happy to consult with you.
Oh, of course.
I would just say, kind of in real Shark Tank style, like what I would need to see to invest further in this would, since a lot of these things to actually have impact, you need buy-in from the people to actually implement the strategies you're researching. You'd need to bring some commitments from one or two agencies, a shared savings commitment that if you were to receive funding, that they would implement and share the savings back or leverage those savings back, just so that you know that they're bought in right away, so you don't create an idea of like research that people can do and just a kind of set of recommendations that don't physically get implemented.
Okay, sure thing, thank you.
I guess I'll just add that I liked your low-hanging fruit examples as well. I mean, obviously you were tackling the big 44% chunk of it with ventilation, but I like that you had a lot of other things mixed in that smaller impacts. But and also, I guess I would just make the really obvious observation that there are lots of labs and other federal agencies around, and even companies, biotechs, and 270 Corps universities, and maybe there's a group of to share some best practices, because I'm sure you've learned some things that they would like to hear about, and vice versa.
Of course, and I do have some of these resources. I've been working with some of the labs and the Department of Energy with publishing some of this. So I do have, there's a Better Building Energy Alliance. Dr. Paul Matthew, he reached out to me to get some of my research and obviously publish it. So we are working on developing those standards and guidelines, and obviously it has resulted from using these energy meters and just going out in the labs. But yes, it definitely will help in terms of, because it is a big thing. It was something that was overlooked before. No one really thought about energy, but now it's becoming something that is hunkering down in research, and it's something that we should pay attention to.